Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem as usual having been chosen from the book Modern Physics by Kenneth S. Crane. Modern Physics by Kenneth S. Crane. As usual we first come to its statement. Calculate the Coulomb energy of KBr potassium bromide at the equilibrium separation distance. Calculate the Coulomb energy of KBr, that is potassium bromide, at the equilibrium separation distance. Students, in the statement some data is not given and it is assumed that we know that data. Definitely we will consult relevant tables in which data about this perhaps compound may be given. Okay, actually dear students, here KBr, which stands for potassium bromide, is similar in sense as we see that Na, capital N and small a stands for sodium. Okay, and C capital L small stands for chlorine, but their combined factor does not but their combined result is not pronounced as sodium chlorine, rather it is pronounced as sodium chloride. Similarly, K is for potassium and Br is for bromine or bromine, but combined result of KBr takes the pronunciation or takes the form as potassium bromide. Similarly, K for potassium and I for iodine, when considered as a collective form, it is not pronounced as potassium iodine, rather it is pronounced as potassium iodide. Okay, so sodium chlorine, sodium chloride, potassium bromine, potassium bromide, potassium iodine, potassium iodide. Okay, basically these things relate more to chemistry, but to this extent chemistry is a part of physics. Okay, so here basically we are concerned with calculating Coulomb energy. Okay, now we move to helping tools. From helping tools we will get some data about this. Okay, helping tool number 1, properties of some ionic diatomic molecules. Okay, sodium chloride, sodium F, etc., so on. 1 2 3 4 5 6 7. Okay, at row number 7 KBr is given. Dissociation energy in electron volt is given for potassium bromide as 3.97 electron volt, while its equilibrium separation is given as 0.282 nanometer. 0.282 nanometer. Okay, so this, that is row number 7, in which potassium bromide is given, is our relevant row. Or alternate version of this tool is given next, and here once again KBr, potassium bromide, dissociation energy 3.94 and equilibrium separation 0.282 nanometer. Okay, we will take this value. Okay, this value is our concerned value. Now we move to tool number 2, which is about electric potential energy of 2-point charges. Okay, electric potential energy of 2-point charges, which is denoted by U, is equal to 1 over 4 pi epsilon naught. Yes students, this term whole, that is 4 pi epsilon naught, is combinedly called electric constant or Coulomb constant. Okay, where Q naught are values of two charges and R is distance between two charges. Okay, yes students, here it is to be noted that in Coulomb's law, square of the distance between point charges is considered, but here we are not taking into consideration square. It is simply simply separation distance between two charges. Okay, next, alternate version of second tool, that is or U is equal to 1 over 4 pi epsilon naught Q naught over R. Okay, same thing. This snapshot has been chosen from some other book. The only difference is that here in place of Q naught, Q dash has been used. Okay, it is the discretion of the writer, discretion of the author. Okay, now we move to tool number 3. This table has been used several times in our previous problems, so for the time being we skip further explanation of this tool. Okay, now we come to solution. Okay, solution. Now Coulomb energy of potassium bromide at the equilibrium separation distance of 0.282 nanometer can be calculated as, dear students, we know that we have taken this value from table. We have shown two tables. Okay, one table from one book and its alternate version selected from some other book. Okay, in both books, in both snapshots, equilibrium separation distance is given as 0.282 nanometer. Okay, now Coulomb energy of potassium bromide at the equilibrium separation distance of 0.282 nanometer can be calculated as electric potential energy equal to K Q1 Q2 over capital R. Here K is electric constant or Coulomb constant and is equal to 1 over 4 pi epsilon naught. Okay, here Q1 Q2, in place of Q1 Q2 we will take E and hence we will get E square over capital R. This is equal to 1.440 electron volt nanometer over 0.282 nanometer. Yes students, here actually we have used this value in place of R while remaining all factor, that is E square over 4 pi epsilon naught is given in table number 3. This is okay, this E square over 4 pi epsilon naught, E square over 4 pi epsilon naught is equal to 1.440 electron volt nanometer, or million electron volt femtometer. Okay, here we do not take femtometer, we take the expression in terms of electron volt nanometer. Okay, so U becomes equal to 1.440 electron volt nanometer divided by 0.282 nanometer. Here nanometer will be cancelled with nanometer, and after simplifying this we will get U equal to 5.1064 electron volt. And this is the solution of our problem which we had to find out. And this is the end of our problem, end of our video. Till next video, Allah Hafiz.